right, I'm recording. I'm recording now. All right, 5-3. Riemann sums. What we have done so far, that remember last class we did or not last class, time before, the left hand and the right hand. Well, we actually have left hand Riemann sums and right hand Riemann sums. They are based on rectangles, right? Left and right hand. So, if we have this function, whatever it is, and we want the area from A to B, right? We want to find that exact area. Oh, shoot. We've talked about how to estimate the area, right? Yes, we slice it into what? Rectangles. We slice it into rectangles, right? I say triangles a lot. I'm sorry. So we slice it into rectangles. Now, and these rectangles are usually of equal length, right? 1, 2, 3, 4, 5, 6, 7. That one is 8, right? What? And we would have, remember, the left hand sum or Riemann, actually, it's a left hand Riemann sum. All of these. Would the left hand Riemann sum be less than or more than? I think it's slightly less, even though we have a little bit of extra here. Yeah, the left hand Riemann sum would be a little under approximation, right? The right hand Riemann sums would definitely be too much, correct? Yeah. Going from the right hand side over. Yes, split the difference. You get a trapezoid. You get the.
Well, that I was talking about the exact thing.
All right, but actually trapezoid, because if we connected it with a straight line.
So rectangles and triangles make a trapezoid.
I was right.
I mean.
In a very roundabout.
Anyway, but if we continue to use rectangles, guys, how would we get the estimate to be closer to the real thing? Make more rectangles, right? If I did 16 of them, it would be a little bit more accurate than 8, right? So let's just remember, we called that delta x was the change in x values, right? What was the y value? If this is f of x. F of whatever. F of a plus delta x.
F of xi, I think.
Yes. So, if we're going to just say, bless you, this would be the height of a representative rectangle, right? The width would be delta x. If we summed them all up, I equals 1 or I equals 0, it really doesn't matter, to n, that would be n number of rectangles, right? And we take the limit as n approaches infinity. This right here is going to give us the exact value of the area. I've got to be honest, sometimes it could be written as delta x approaches what? 0. And then you would say I equals 0 or 1. You probably would say infinity here. I don't know. It could be n. F of x sub I. A lot of times this book uses the star thing because if I start at 1, I'm actually doing a right-hand Riemann sum, aren't I? If I start at 0, I'm actually doing a left-hand Riemann sum.
Well, I guess you could say like x sub I minus 1 minus x sub I, and then there'd be for left or right hand. Well,
Yeah, they put the star there because it could be left, right, or it could be the midpoint. It really doesn't matter, because as your delta x approaches 0, or as the number of rectangles that you draw goes to infinity,
So delta
the
x
left
being
and the
width of
right become so close together you can't distinguish them. Does that make sense?
Yes.
So the delta x being the width of the rectangle.
Delta x being the width of of every single rectangle, yep.
And then also, and then the.
So I have seen this, if you ever see this, while we don't have the skills to actually solve these infinite limits with series or summations, we really do not have the skills to do it by hand.
Can you prove it? I'm just kidding.
Yeah, let's
I can, but it would not be worth your while to even look
Yeah.
at it, because
But
it's a
fine.
good 2 weeks to get us there.
So you should do the proof?
Anyway,
Oh, one more question.
my point is, if you see either of these, it becomes what we call a definite integral from a to b of the function. And what is delta x always the same as from the 4-7 or 4-8 section?
Oh, dy.
dx.
Oh,
Delta x and dx are exactly the same. This is now the new thing called a definite integral. What makes it definite?
It's got a limit on either side, however it's.
It's got the starting point for the x's, and it's got the ending point for the x's.
So,
Is this the one you can pull
This
in
is like the shoot proof.
You can, yeah.
sorry, I realize it's probably pretty down. I'm assuming the f of x I referring to the equation itself. Or no, not the equation, but. no, actually, what
The f of x sub I is the y value for these changing x values that start like, and you'll see it, on an interval. They will give you an x interval.
is the y value for each box?
The y value for each box as you move from A to B. Does that make sense?
Yes, ma'am.
Okay. Anybody else? So,
Wait until it starts. Like,
what you're going to do today from graphs is, you're just going to, well, from,
Testing.
there's about 3 or 4 different types of problems you're going to see. One is give the definite integral. Write the limit as a definite integral on the interval a to b, where c sub I is any point. See, they don't use x sub I, they use c sub I. It don't make no difference.
Use font? Are those words? Seats about? Seats about?
So the thing we were doing before is called an indefinite integral.
Yes, what we did before was an indefinite integral. And
The water?
So that's like the integral except that has no end point. It's in your stomach, but it's still in water.
No, I just drank this whole thing.
oh, they also include, they don't even call it plain delta x, they call it delta x sub I. Oh, what the heck? They don't even do a delta x, they do delta approaches 0? I've never heard of that. That's the first time I've ever noticed that. They left off the x.
I think this was a grad.
I think that they're playing.
Anyway,
Some intern.
so, what,
Brandon Larson's just insane.
We can help with that.
I think he's literally named after.
here's what they give. They give this limit definition with a summation. We know that delta whatever becomes a what? Dx. The integral, the limits of integration are 1 and 3. These are called limits of integration. We start at 1, we end at 3. And what is the function itself? 3 over x squared. This is all we're looking at today, is actually setting up what these limit series things.
So we're just converting it to a different formula?
We're not gonna actually solve this yet.
Not yet on this one,
Okay.
but we are going to use geometry to solve some of them because they're that easy. Yeah.
The CI squared portion, now, I realize it's equivalent to x squared, however, so why would you write it as CI squared though?
No idea.
Wouldn't you write it, wouldn't you?
As x sub I squared.
Yeah,
I don't understand why the book brings in these C's all the
I'm gonna
time.
write it as x, I'm gonna write it as x.
And I also don't understand why they just say, this is what they have. Delta
Alright, then,
approaches 0.
Ew.
But-
also-
But you honestly, it could be, I've seen it on the AP things, the limit as n approaches infinity. I equals 1 to n of like, I've seen it like this, like 3x sub I plus 2x sub I squared delta x.
Also, one more
Setting
question.
it up and that's it.
Also, Ms. Washington?
You're setting it up and that's it.
Alright, two more questions, one of them being, if I put x of I squared instead of ci squared, is that right? Just because it seems less
Yes.
confusing to me. Also,
So
for the
seven
delta x,
on
for
the
the
top
delta
of
xi, does the I interfacing with the delta x have any actual impact on it, or? In other words, where you have up
The
top
delta
two-
x, we have been using, oh, yeah, they use delta x sub I.
Yeah.
So what they're saying is actually the width of all their rectangles don't even have to be the same width.
Yes, however, in this case, we're working.
But
with
we've
these.
only been using equal widths of rectangles, right?
Yes. So could I just put delta x?
You could just put delta x
Alright,
and
cool.
we're
I'm gonna
fine.
keep things as.
All right, so this one, what's our definite integral gonna be? Integral from 4 to 7,
Then just be 3x plus
3x
2x
plus
squared.
2x squared dx.
So all we're doing is rewriting this?
All we're doing is translating this, so just,
For now.
this is, yeah, for now. This is one of those things that, just like that long limit definition for derivatives, y'all forget. If I tell you to find the limit as h approaches 0 of the sine of x plus pi minus the sine of x. Oh, I don't know what I'm doing. Pi plus h minus the sine of pi over h. Y'all think, oh my gosh, I gotta do some long limit here?
Oh my gosh,
You
is
know
it
it's just sine of pi.
This
Oh my
is
God,
the
there's a long
derivative formula, or for pi, right? And what's the function?
Sine of x.
Sine of x. What's the derivative of sine of x? Plug in the pi is what? Negative 1.
Would it not be negative cosine? Because it's positive sine.
The derivative of sine
I'm.
is regular
He mixed it
cosine.
up.
Okay, it's
Yeah, he mixed it up in physics
It's because
too.
we
Yes.
just went
Yeah, it's 'cause
backwards.
of derivatives.
Yeah, I agree. That happens all the time. All right. So,
See, it's
so
normal.
just like we forget this long formula really has shortcuts, that's the same thing that happens here. You see this big ugly thing and you're like, oh my gosh, how do I do this? Oh, it's just a definite integral. And once we start definite integrals, they are going to be easy, even by hand, even without the calculator. All right? So, now, set up the next type of problems. Set up a definite integral that yields the shaded area.
So they're backwards.
Sideways.
How about sound even indicates?
Scooby-Doo? Right.
It indicates these office nodes.
Oh,
Their voices, they're running
It really is good, but.
All
Alright, so give me the definite integral that would yield this area
So the integral thing, and then,
from
from
0 to 2. Guys, I am giving you some pointers on reading definite integrals. You read it from the bottom to the top. The integral from 0 to 2 of
x squared.
dx. That's all I'm asking for, is the setup.
Wow, this homework is gonna be so good.
Yeah, I don't understand anything about this. I'm so stuck.
Well, this
Okay, we gotta stop here.
No, I just thought we would have to like.
No.
No.
Sketch no bad, sketch bad.
Gonna put him in.
Yeah.
I hate drawing, I broke my hand.
I like drawing. I think I have purple homework. Is this the third time?
Yep. So, type 1, diabetes.
Diabetes.
No, I'm just kidding. Type 2, type 3. I don't know, every time I say type 1, I always just think type 1 diabetes.
My mom has diabetes.
She does.
Yeah.
Oh, that's such a,
Yeah, they thought I was gonna have it, and then I didn't pass out in 5th grade, so it's fine. Hopefully.
Let's just not give them food and see what happens.
all right. Sketch the region and find the, yes.
Forgot how it is. They're just voicing them too high. I wish I knew where Scooby. I took one for the entire
All right.
Now the walls are crawling around and stuff. The walls are
Yeah,
crawling
guys,
around.
can you graph 4?
It's gonna be y equals 4.
Y equals 4. 1, 2, 3, 4.
Oh. What?
And this tells us to go from
-2 to 3.
-2 to 1, 2, 3. So shade up that area.
Oh, it's just one
Can we
rectangle,
plug this on
It's just one big rectangle.
so we actually could solve that.
Can we plug this on the calculator and make sure?
Absolutely no. So what is that exact area?
7.
20.
4 by
1,
5.
2, 3, 4, 5 times
20.
4. The exact area is 20. Well, if they gave you units, it would be square units,
My
right?
old geometry teacher made us write 20 square units.
Yeah, you did have to do this.
My old
Well, I'm
geometry
proud of
teacher
him.
was really good at
I don't
that.
know if teacher left.
I will show you
Wow, Vargas can-
while we're here, while I got the calculator. Look at math 9. Look at math 9 and put your phone away. Look what math 9 does.
Oh my god.
Oh, word. -2, arrow right, 3, 4. You gotta put that X in there.
Wait, why do you have to put the X in there? What is the point of that?
The point of that is you are integrating with respect to X.
20.
Everything is related to X's.
Because what if it's like,
So
Because you
X
can have DYs and you can have D whatevers.
So X can be any
DZs.
number, so couldn't you also put like XT, XO, I mean DO, DT, or whatever? Like, what's the difference? Is X-
Not much, but, you know,
What buttons did
math 9.
Yeah, X was the, or
If you forget when you hit math and you arrow down, it's called F int, integral derivative. Math 8 was the derivative, math 9 was the integral.
So is that like, what is that F stand for?
Function integral, I guess, I don't
Did
know.
I?
Yeah.
Yes, you have blood on your.
I got an extra pair.
All right.
Why?
what would happen?
You didn't even take it the last day, but you still brings an extra one
Miles,
in.
Jared
I always
told me
have
that I
an
saw you at
Did
a
you
track
dribble?
meet and that you had like
Doesn't make any sense.
like running
actually
pants,
paced your
running
run
shorts
today,
under
just
your
makes her a little
jeans.
bit-
Yeah.
All right, people,
Who is this?
Jared.
Oh, yeah, Jared and I are both management. Sorry.
this is being recorded. I'm not really exactly sure what's gonna show up, but,
Oh, right.
Track.
We're talking about funny and track.
okay. But the back row was not.
Oh, I don't know.
No, we were.
I
We were talking about his extra pants.
Okay. So,
No, that's all.
how do we graph y equals 6 minus x?
It's
Negative x plus 6. 1, 2, 3, 4, 5, 6. Down 1, over 1. And we're going to go from 0, 2, 3, to 6, aren't we? And if we down 1 over 1, it's going to end up right over there at 6, isn't it? So it's a triangle, and we can use geometry for that as well. What's that geometry formula? 1/2, the base is 6. The height is 6. Half of 36 is? Shall we check it and just make sure? You already checked it?
That was the first thing I did when you wrote that problem.
Yeah, to answer your question, that yes, I'm sorry.
what?
To answer your question, that yes, I do in fact, when I run track, I do in fact wear.
Is this still about your pants, man?
He's still talking about his pants.
I'm sorry, I'm not.
My mind's still in my pants.
Okay.
Oh.
Landon, you can't say
That wasn't, no.
This is being recorded. You can't say that.
Landon's
No,
not
no,
allowed
no.
to do like that
No.
school anymore.
This Washington is gonna kill.
I'm sorry, that's not.
We're so sorry, Miss Washington.
You can put them in the hall.
Not me, I didn't actually
Yeah,
do anything
she's
this
gonna
time.
like post this.
Hey, guys, this is one instance.
Alright, yeah.
When even when we get to doing all of these things by hand, and they're gonna be just easy as pie or whatever to do, this one, we will never be able to do by hand. But we can do it with geometry very easily. Now, you may not know exactly what this graphs to start with.
Wait, what do you mean we're not gonna be able to do it by hand?
This one, we have no shortcuts. You can do it on the calculator and it'll give you the estimate, but
So where brute force is the numbers.
Wait, sorry, so, what do you mean by we can solve it by geometry, but we can't do it by hand?
I mean, once we learn the shortcuts, this one is not doable by hand.
Miss Washington, okay, I got you.
Once we learn shortcuts, if you see this, you must think of this as the top half of a circle.
Will they trick you like that?
That this could be, yeah, I would say.
Does that not just simplify to 2 minus x?
No, it does not.
Oh.
Powers are not distributable over addition or subtraction. You can't say 4 minus x squared to the 1/2 power is the square root of 4 minus the square root of x squared. You can't distribute powers over. That's like saying 4 minus x squared squared is 16 or plus x to the 4th. It's not. You FOIL. And so the square roots or the cubed roots also cannot be distributed. So no, you can't do that.
Now I know where I can.
Add the x squared over. Your entire life is a lie. I'm so sorry.
I was one of the guys that you could just, no wonder I get so much.
Look, it's P theorem.
All right, now, everybody understand, when you see this setup, the square root, especially if they're two perfect squares, this is really very much like a circle, isn't it? Do y'all remember the equation of a circle with radius what? In this case, 2, the square root of 4, right? But because it is a square root that's already there, this is understood to always be positive, correct? And so this literally is just the top half of a circle with radius 2. And so literally, we know the area of a circle is what? Pi r squared. So pi times 2 squared, half of it. Yeah, 2 pi is the exact area.
That's not a very good circle.
Math 9, negative 2 to 2.
Can you draw a perfect circle for me, please?
Just freehand it.
Or just use that, what was it, rotating arm technique?
That's essentially.
It even had to think a minute, didn't it? And what is 2 pi?
2.10.
I mean, this was awfully close.
It's off by
No,
0.005.
All right, question.
Oh, no.
I'm not gonna draw a perfect circle, sorry.
It's off by 6 zeros and a 5.
What?
All right.
She won't drive because she can't.
Now, there are some little, maybe laws or properties of definite integrals.
Is this gonna be your diabetes type 4?
Diabetes? What?
We're gonna
Type
use
4
the properties for type 4 diabetes, yes.
Huh?
I'm just kidding.
What's the front row talking about? You're talking about us. You're talking about type 4 diabetes.
Type 4 diabetes, you were literally made of sugar.
Guys, if we have a constant multiplied by the function, then the definite integral, we could just pull that constant out and like not have it mess up things, okay?
Can't you also do that with the summation?
How does that work?
Yes, you can do that with summations, yes. And the other is if we add or subtract. We can add or subtract the definite integrals, right? Separately. In fact, I'm pretty sure we did this one for the indefinite integrals, didn't we?
Yeah, we did.
Yeah.
Are these literally like log rules?
Not like log rules, but. Oh, there's a couple other things too. If,
Oh, that's not like ball
the integral from A to C is actually the integral from A to B plus the integral from B to C. Now, I believe B doesn't even have to be between A and C, but like, no, all it's saying, if I ask you to go from 0 to 6, I could go from 0 to 3 and then add from 3 to 6.
So it's like the sum of segments for geometry.
It's like segment addition or it's integral addition postulate or whatever.
What's all that junk on the right then?
Or it's almost like transitive. This
Yeah.
is if we add or subtract two portions, we can add or subtract their definite integrals. This is an equal marks. So there are 3 little pieces that I'm bringing out. Oh, there's one more.
Don't write it down right.
Don't make me watch the video.
Oh, wait. Leave the video.
The integral from A to B would equal the opposite of the integral from B to A. In fact, so in this one, if instead of asking you for the integral from 0 to 6, if I had said 6 on the bottom and 0 on the top, flip it and do the opposite, yeah, it would just be negative 18.
So what is the bottom one? The bottom left one?
This one, it's almost like a transitive. If I want to go from A to C, I can go from A to B and add it to B to C.
Oh,
I just showed you 0 to 6. I could go 0 to 3 and then add that area to this area, right?
And that just makes it simple and we can choose whatever B value we want. If
Yeah.
it's not being provided.
Let me give you,
same words.
oh, I don't want to jump to type 5 but diabetes, but let's do type 4 first.
What is this diabetes?
I'm just kidding.
No, I'm so like what?
You
Like I said, that's the point where you're entirely made of sugars. You
My
are.
type 5 was
You are
made of
literally a golem.
sugar.
If you paid attention.
Are golems made of sugar?
No, they made
That's our inside joke.
Bird from Candyman.
And you're an outside joke.
Did you come from Cadillac because you had type 4 diabetes?
I'm gonna use that next time.
Yeah. I think that's the WKF line.
That right there is how you get people to like you.
Prom date.
Yeah.
You come from Candyland because I'm pretty sure if I drink your blood, I would die.
Man, mosquitoes must love you because your blood is sweet.
I bet your blood tastes like Shirley Temple.
Yeah, you were paused that entire time.
Okay.
All you do is, welcome back after a short intermission.
Given some of these problems, what if I just ask you to find the definite integral from 2 to 2?
You just plug it too. 2 times 2 is 8.
No. Think of a graph.
Oh, there's nothing. So you
There's nothing.
put it in
If
zero.
I'm going just from 2 to itself, there's like no width at all, correct?
It's infinitely
This is
small.
going to be 0. The integral, if you wanted to add to your little property list, the integral from a to a of f of x dx is just 0. Now, this one, I didn't give myself a lot of room, but that property that says we could pull the 2 out, integral 2 to 4 x cubed dx, right? Minus integral from 2 to 4 of x dx. I'm splitting this up over the addition or subtraction, and I'm using that property that says I can pull a coefficient out. So x cubed from 2 to 4 is
60.
times
2.
is
120.
minus the 6, correct?
Yes.
Wouldn't you also multiply that by 2?
Nope, it's not. There's no 2 in the original function going with the x, right? If it was in parentheses, yes. What was your question, Miles?
I was thinking.
We're good?
Yeah, I was just thinking. I was just thinking.
All right,
Because when you plug, sorry, I did. When you plug that in, when you plug it into the x, you plug in the larger of the two, the larger of the two. No. Between 2 and 4. Oh no.
literally, I'm using this given information. Guys, I haven't actually seen a problem like this on the AP exam. What I've seen is g of x here,
Oh, I'm blind.
f of x here, and like z of x. I'm just making it up. So, I mean, literally, this one would be g of x plus 4 times z of x, correct? So, I understand, but, I mean, if you're given this thing right here, once we go through next class, you will never have to use this kind of set of givens again. So let's just change it to g of x. 4 times z of x. Yeah, I've changed these. Because now, what is the integral from 2 to 4 of g of x? Plus 4 integral 2 to 4 of z of x. 60 plus 4 times what? 68. I could have just left it the same and you would have gotten the same answer, right? But I wanted to show you how you would probably see it. Like, they're not going to give you the explicit functions because in a minute, y'all are going to know how to do those and the givens will not even be necessary. But they will present it like this. they'll say, oh, we don't know what g of x is. But if I know the integral from 2 to 4 is 60, what's the integral from 4 to 2?
Negative 60.
Yeah, the opposite of the integral from 2 to 4, right? Which is negative 60. Done. Are we good there? Okay. No, the last type of problem is given these, because remember how we said we can add up little pieces and stuff, right?
Yeah.
I want us to understand piecewise functions definitely show up where they have graphed them. And I also want you to understand if this is the graph and I'm finding the area below the x-axis, there is a difference. Or if I'm sorry, if I'm finding the integral, let's just call this g of x. If I'm finding the integral from negative 2 to positive 2 of g of x, there is an issue. It is not just an area. Now, if they said find the area between this function and the x-axis, then yes, it would just be an area, half of a circle, half of pi r squared, 2 pi, correct?
Yeah.
But the definite integral from negative 2 to positive 2, if that area is below the x-axis, it is actually going to be negative because it is below the x-axis, right? Half of the circle, pi times 2 squared.
Why? How can you have negative area?
It is a definite integral that is negative. We've talked about definite integrals meaning an area, but it is actually... Well, guys, if you think of those summation things, can somebody tell me what, just one of these rectangles, what's the y value? It would be negative. It's something you gotta accept. If the graph is below the x-axis, you gotta make the area negative. I mean, the definite integral would be negative.
So if they asked you for a definite integral, it would be negative 2 pi, but if they asked you for an area, it would be the absolute value.
It would be positive 2 pi, yeah. All right, I'm just making it some random set of lines and whatever. All right, so we've already talked about the integral from negative 2 to positive 2. Could you tell me the integral from 0 to 4?
When we feel like split it up.
We definitely split it up. 0 to 2 is what part of a circle? It's just a quarter of it, right? So it will be negative pi over 2, correct? Or pi.
Wait, that was pi.
Yeah,
It's just pi. It's half of the half, right? If this was already a semicircle, then cut that in half, we get regular pi, right? But, so this is the integral from 0 to 2, plus
Oh, so this is why you're one.
this, yeah. Well, I'm going to go 2 to 3, because it's a what? Triangle. What's that area? 1/2, 1 times 1. And this one is just 1 whole square. So 3/2 minus pi is my integral from 0 to 4.
That's big.
Yeah.
Why is it 2 pi for just a half of a circle?
Well, because the radius is 2. Pi r squared, it would be the area of the whole circle, right? Half of it, because it's only half of the circle. So 4 pi times a half is 2 pi. How about the integral from 4 to 6? That one feels a little bit weird because,
It's a trapezoid again.
well, it is a trapezoid, or cut it in half, cut it and make it a rectangle with a triangle on top.
I told you trapezoid was a rectangle and triangle.
What's the area of rectangle?
Three.
2 times 1, 2, plus 1/2 base times height, right? What's the base? 2. What's the height? 2. So 2 plus 2, 4. It is that easy. Let me go a teeny bit weird. How about if I went from 0 to -4?
It would have to be negative. Right?
It's the same thing, but negative. No, it's different.
Well, I'm gonna just say, let's take the opposite of -4 to 0. That's how I'm gonna think of it first. So I'm gonna say negative. And from -4 to -2, what is that area?
It's negative.
1/2 base times height. It's just a 2, right? And then, yeah, it's gonna be a negative pi for here, right? Because from here to here was pi, so that one's gonna be pi. But it is negative, right? So what is the actual answer to this one? Positive pi minus 2. If we're going from 0 to -4. So we do, I'm just this kind of stuff shows up on the AP exam, and it's easy peasy problems, but don't forget, easy peasy. Don't forget to just do negatives if it's below, and do,
I have a bag of sugar.
Is that the homework time?
homework time.
Type 5 was literally one molecule of sugar.
That's negative.
You regressed out of here.
Okay, no, I was thinking that was negative. I thought that was.
This is above the x-axis, right? So this one is a positive, that one's a negative, but because we had to do the opposite of it, we switched both of the signs.
I thought it was gonna be the inverse. That was 0 to 0.
All right, here's your assignment. 314 to 316. Can you read it?
Is it on Blackboard?
Yes.
9 through 21.
33 to 47 odd. 46 and 48. These are the graph ones that I just really want y'all to practice because they show up. And there's like always some kind of graph one. On the
What is the PP, like, instead of PG? What is it?
more than one page, I don't know. You know, when I was